Hey everyone, this is 3-2, factoring special products. I told my kids, really this is just a, hey, if you see it, fantastic, because all of these can still be factored just like we normally would, but they're special products only because maybe they have a slightly different way they'll write the answer, or maybe there's a particular pattern that if you see the pattern, it might make things go a little faster. Um, but if not, it's not a big deal. We can still do these the way we have. Now, we started with this, where this is simplifying, and I explained, look, if I have 5 squared, this is just 5 times 5, right? Of course, that's 25, and we would get to our final answer. But with this, I want to make sure that you understand that it's y minus 5 times y minus 5. And then you FOIL, and we know how to FOIL from previous videos. We get y squared minus 5y minus 5y plus 25. Those combined there. And we did the same thing here. X plus 1 times x plus 1, and we FOILed. Then we got here, and you can see there's no work, but there's an answer. Well, what happened? Well, like I said, these special products have pattern, very specific pattern. Y times y became y squared, and negative 5 times negative 5 becomes 25. But how did we get this? Well, if you take this negative 5 times y, so this negative 5 times y, you get negative 5y. And then it appeared a second time. Over here, 1 times x became 1x, and it appeared a second time. So all we have to do is take that times this, the negative 5 times y, and then double it and get that here. 1 times x, and then double it and get here. So negative 7 times 3x is negative 21x. So when we double it, it becomes negative 42x. The negative 7 became 49. The 3x, 3 squared is 9, and x squared is x squared. Same thing over here. X became x squared. Negative 2y. Negative 2 times negative 2 is positive 4. So positive 4y squared. Negative 2xy doubled became negative 4xy. And I said, look, otherwise we're just foiling these like normal. We get the same answer. So it's not a big deal if you can't recognize the pattern. So then we moved on to difference of squares. And we talked about this already. X squared minus 25. If this can break down to x times x, and this can break down to 5 times 5, and difference meaning subtract, this was 1 plus 1 minus, where a middle term is gone. If you see it, it's a quick jump. If not, you factor it this way. Just remember there's a 0 on bottom. Negative 25 on top, 0 on bottom. 5 and negative 5. That's the 5 and negative 5 we have there. But if this can basically square root into something even, and this can square root into something even, and there's a subtraction sign that goes with it, because remember, we can't square root the negative 25. We'll get an imaginary number. It's not what we're looking for. But if this 25 can, then we do it. So I put up x squared minus 121, and they said, well, that's x times x, and that's 11 times 11, and there's a subtraction sign. Boom, there we go. Now, like I said, this is the same kind of thing, 4z squared. This is just 2z times 2z, and that's just 1 times 1, and it's still 1 plus 1 minus. If we do it this way, negative 4 on top, 0 on bottom, and then we finish it like we would, this would reduce to the 2z plus 1. This would reduce to the 2z minus 1. So if you see the pattern, fantastic. If you don't, and you still do it this way, you still get the same answer. It's not that big of a deal. Now I want to move some of this stuff out of the way real quick. I'm going to come back to this. There we go. This had some, I don't remember what the instructions said, but they basically want you to show your work. Okay. Now, first thing I did is I said, well, let's put this in the calculator and see what we should get. And we got 612. I said, okay, now, this is just like x squared minus y squared, where this is x times x, and this is y times y, and that means 1 plus 1 minus. So it's the same thing. It's going to be 54 times 54, 54 squared. It's going to be 48 times 48, 48 squared, 1 plus 1 minus. So we said, okay, this adds to 102. This subtracts to 6. And then when we multiply them, sure enough, we get the 600. Then I brought this on. I said, well, what happens if that's a plus? Can we still do this? And, well, maybe this is also a plus. And then all of a sudden, this also becomes 102. And then we have 102 times 102. Well, oops. So when I do 54 squared plus 48 squared, I get 5,220. If I do 102 times 102, which looks like it should have worked. I actually get 10,404. And I say, look, these, like, I can't even count these as like, oh, this is double, because it's not, because that should say 40 instead of 04. And it's the stuff like that that it's the reason why this has to be a subtraction sign. Otherwise, this pattern doesn't work. So I can move these over here and hopefully not confuse myself in the future. Factor each polynomial, n squared plus 8n plus 16. Well, factor it. 4 times 4 is 16. 4 plus 4 is 8. And I said this should trigger that you have a special case, because this means these are going to look exactly the same. And just like the very first slide, instead of leaving it like this, we're going to write it like this, where it's n plus 4 quantity squared. On a multiple choice test, you'll probably never see it this way. They'll always write it this way. I don't want to necessarily say maybe because they're lazy, but like this is the proper way of doing it. I mean, they could write it this way, but this is the proper way. So we did the same thing here. 4x squared minus 12x plus 9. We did this, and we got -6, -6. I said, look, if those are the same, it should trigger a special case where we could solve it this way and get 2x minus 3, or we could say 4x squared is 2x and 2x. Because this told me they are the same, I know it's not going to be 4x and 1x. It's going to be 2 and 2. 9 is 3 and 3. And to get that subtraction there, these both had to be subtract, because when I FOIL that times that, I get the one of these -6s, and this times this, I get the other -6. That makes my -12. Again, write it this way to finish. Now on this one, we had fractions. Fractions not a big deal as long as you know how to get rid of them. So it took us a while to figure out why we chose 9 to multiply both sides, because this is just an equation. I got something equals 0. Well, remember with equations, I can do whatever I want to one side, provided I do it to the other. So I have 9 times x squared. 9 times 2/3 x, and 2/3 of 9 is 6. 9 times 1/9 is 1, and 9 times 0 is still 0. Question was, why didn't we use 3? Well, because the 3 would have gotten rid of the 2/3. The 3 would not have gotten rid of the 1/9. We would have still had a fraction. Multiplying fractions, you just multiply straight across. And remember, 3, what's that extra dot right there? I don't know what that is. 3 is just 3 over 1. So 3 times 2 is 6. 1 times 3 is 3, and that reduces. But this one didn't work. So we had to use 9 to get this 9 to go away. Well, once we did this, we factored 3 and 3. Oh, those are the same. We got a special case. So we can go 9x squared is 3x times 3x, and 1 is 1 times 1, and that would be positive. Or we could work it out this way also. Now, problem is we weren't done. We had this equals 0. And this kind of leads us into 3.3. If I say equals 0, then I still have to solve this. It still says equals 0. So to get rid of the squared, we're going to square root. Then it just becomes a two-step equation. Subtract, divide. Here's the actual answer, because it wants to know x equals what for all of this equals 0. My answer is -1/3. I said that only we have one answer here, and we technically have two, but we're taking this, and it's a little bit different when they look different like this. If I have two different things and I multiply to get 0, I just need one of these to equal 0, because 0 times whatever or whatever times 0, either one's going to get me 0. So if x plus 2 is going to equal 0, then x equals -2. If I plug in -2 there, 0 times -5, because x is still -2, equals 0. If I want this one to be 0, I have x minus 3 equals 0. So x is +3. 5 times 0 is still 0. So that's a lead-in into 3.3. Here was the assignment for that. So hopefully, like I said, if you see the pattern, fantastic. If you don't, it's not a big deal. Just work it out like normal, and hopefully you see the pattern at the very end by going, oh, these two were the exact same answer.